Okay.
So, yeah, for those of you watching, we record our Wildlife Wednesdays and we post them on our Facebook page and our website. We also have a YouTube channel. So if you want to revisit anything from this presentation or past presentations, feel free to hop on there to see those. So we will be recording this. And with that, I'll say welcome to everyone to our Wildlife Wednesday presentation tonight. Revelations from an aerial perspective, how hungry whales work smarter, not harder. We're really excited to have Madison here with us tonight. She's gonna introduce herself at length in a little bit, but really excited for this presentation. So thank you all for joining. And I'm ready for our next slide. So just a few rules before we start. No Zoom bombing. If you haven't experienced this, congratulations. I hope you don't. So we're keeping the video off and the mics muted to conserve bandwidth and to keep focus on Madison's presentation. We encourage everyone to view the presentation in full screen mode. Madison has some really awesome footage of whales from a drone, so it's worth seeing in the big screen. And if you have a question throughout the presentation, at the bottom of the screen there's a little chat icon, and you can submit questions there, and then we'll have a Q&A session at the end. So I think that's it. And an introduction to Alaska Wildlife Alliance. My name is Nicole. I'm joined by Mandy, who's our deputy director, and we are the Alaska Wildlife Alliance. We've been advocating for Alaska's wildlife since 1978, which is pretty old by Alaska standards. We weren't a state much long prior to that. And our mission is to promote ecosystem-based management for Alaska's wildlife. So really combining ethics and sustainability in wildlife management around the state. We have a chapter in Juneau, so welcome to the Juneau folks, as well as programming in Kenai Peninsula and the interior and Anchorage. So we are member supported. You can join our alliance for $35 a year. We're also available for donations through Amazon Smile, Roundup. For Alaskans, we're a Pick, Click, Give organization. And for federal employees, we're on the combined federal campaign. So if you like this programming and would like to support it, those are some ways that you can help us achieve our mission. And thank you to the members that I see on here tonight. Again, without your support, we couldn't do the work that we do. So thank you. Madison, ready? Great. And if you're not following us on social media, especially Facebook, we encourage you to do that. That's where we do a lot of our wildlife advocacy updates and news. We also have postings of our educational programming and events, our citizen science projects, etc. And then we also have to throw in some wildlife fun in there. So that's a good way to stay up to date. And you can also join our mailing list, our email list on our website, which is akwildlife.org. And speaking of advocacy, we have a very big project currently going on the Kenai Rule. For those of you who aren't familiar, the Kenai National Wildlife Refuge is undergoing some proposed rule changes. And those changes would change regulations and open the refuge up to areas of trapping and also different methods and means of trapping than we've seen before. It would permit brown bear baiting, which you can see there's a photo of a brown bear at a bait station, which is essentially human food in a barrel, and then as the bears eat it, they're shot. It would also permit firearms to be shot within a quarter mile of the Kenai and Kasilof rivers during certain parts of the year, and many more. And the comment deadline for this is on Monday, August 10th. And Mandy put in a chat a link to the Federal Register where you can submit a comment, as well as our fact sheet where you can help draft your comment. And we do have a short video, it's 2 minutes, to give you a rundown on this particular project, and then we'll hand it over to Madison. Thanks, Madison. So if that's a project that's important to you to protect the Kenai National Wildlife Refuge from those types of practices being allowed on the refuge, visit our website at akwildlife.org for all the information on how to comment. And there's also the links to those resources in the chat function of this presentation. And again, the deadline is August 10th, which is Monday. So, thanks, Madison. And going forward, again, as I said, if you've missed previous Wildlife Wednesdays or you'd like to revisit this talk, we do post, we record these videos and then we post them online on our website and on Facebook. So we invite you to look at our previous virtual Wildlife Wednesdays. You can also view the teaser trailer for the documentary we're working on with filmmaker Rainey Newell about Denali's wolves. That is on our website as well. And then the first Wednesday of every month, we have Wildlife Wednesdays. On September 2nd, we have avian influenza in seabirds of Beringia. I think I'm saying that right. And on October 7th, we have Unraveling the Mysteries of Bats in Alaska. So a lot of fun topics coming up. Thanks, Madison. And with that, I'm very excited to turn it over to Maddie and her beautiful presentation. Thanks, Maddie.
Thank you so much, Nicole. And thank you, Mandy and Alaska Wildlife Alliance for having me here. And I cannot see you people out there, but thank you all for coming. And I deeply understand the issue of bandwidth with internet. I'm actually not in this beautiful meadow, in case I was tricking anyone. I'm in a grocery store parking lot in Anchorage. So I'm actually gonna turn off my video as well. Then also you can see the slides better. You don't really need to see my floating head, and I'll turn it back on at the end for questions. So before I dive into the talk, I thought I would give you a little background about myself, so I'm not so much of a stranger chatting to you. So I grew up in Michigan. I spent my childhood running around on the sand dunes and playing in Lake Michigan. At a young age, I was mesmerized by the water and love the ocean. But of course, if you've been to Michigan, you know, or the Midwest, you know, there's no ocean creatures in those lakes. So I imagined as many of them as I could. And since as long as I can remember, someone asking me the question of what I wanted to be when I grow up, my answer was always very confident and very consistently, I want to be in the NBA, and then I want to be a marine biologist. Well, about maybe like junior high or high school, I realized that 5'5", I definitely was not going to be the next MJ, as well as I really kind of fine-tuned and honed my passion for the ocean. So I went from Michigan to Hawaii, and I attended the University of Hawaii Manoa, and I studied marine biology. Now, Hawaii is pretty boring. The creatures are not very cute at all, and there's absolutely just nothing to do, and the scenery is just boring. I have no idea how people are reacting. The silence of the ether is deafening, but in case you didn't know, I was being extremely sarcastic. Hawaii is an incredible place and a wonderful place to study the ocean. And when I was about to graduate, I did what any undergrad does. I panicked a tiny bit, and then I went to Uncle Google and I tried to find some jobs, and lucky for me, I came across a job in Alaska. So I went from Hawaii, humpback whales breeding grounds, and I went north to their feeding grounds. So I went to Sitka, Alaska, and this picture is of the Sitka Sound Science Center. If you haven't been to Sitka or the Science Center, you definitely should go. You're missing out. It's a beautiful place. And I worked there for several years. I was a part of a lot of cool projects and did a lot of science communication. And I worked with Sitka Whale Fest. If you don't know what Sitka Whale Fest is, it's this incredible festival that happens in November on this little island that Sitka is on. And it is about celebrating the ocean as well as just bringing the science to the people. So we bring tons of really cool scientists to share what they're working on. And this is a shameless plug because I'm actually on the science committee for Sitka Whale Fest. So you definitely should go. And this year we are going virtual. So it'll be very similar to kind of these Wildlife Wednesdays. And we're going to have some speakers from different parts of the world. So it should be really cool. But in the future, when we all can travel again and it's safe, definitely get yourself to Sitka. It's a beautiful place. So while I was in Sitka, I also worked at the Whale Lab. That's at the University of Alaska Southeast. And these were my lab mates. We did some great work on sperm whales and humpback whales and killer whales. And that woman on the left was my mentor. She is Jan Straley, who is a humpback whale researcher legend. So great mentor. And this is where I started my journey in whale research. And I started my master's project with the University of Alaska Fairbanks. And that is what I'm going to tell you about today, the work I did while I was doing my master's. So this last fall, I actually finished up and graduated. So I moved from Sitka, which was a little heartbreaking because I love that community. And now I am in Anchorage. Sorry, for those of you who aren't around Alaska, hopefully you can maybe look at the Gulf of Alaska and figure out where we are. I know we have a lot of people tuned in from different places. So I moved up to Anchorage, and I'm currently working with NOAA. I'm a fellow doing some projects with Cook Inlet belugas. So I went from having this in my backyard to having this in my backyard. And again, I don't know what your responses are, but the funny thing is I find people have very different reactions to both of these photos. Like the one on the left, there might be some oohs and some ahs, and then on the right, there might be some giggles. But it's funny because essentially the animals are doing the exact same thing, right? But because marine mammals and whales are so mysterious to us, we kind of perceive them in a different light. And so it's funny because people are extremely passionate about taking that perfect photo of a fluke or the tail of a whale. And that's what this is, a tail of a humpback whale. But it's essentially exactly the same thing as if your friend came up to you and was like, dude, I just got the most epic photo of moose ankles yesterday. I mean, they're the exact same thing. So it's very funny how, as human beings, we perceive different animals differently. Okay, enough of that. So let's jump in. So my talk is Revelations from an aerial perspective, how hungry whales work smarter, not harder. And again, this is work I did as a graduate student with the University of Alaska Fairbanks. So humpback whales are a top marine predator. And since the end of commercial whaling, their numbers have increased. And with this increase in numbers has increased this controversy between this top marine predator and fisheries. Because these animals are eating economically valuable fish, as well as the prey that those fish rely on. Today I'm going to focus on humpback whales eating hatchery-release juvenile salmon. And just to orient you again to kind of where this is happening, again, I said I'm up here in Anchorage. So for those of you in Anchorage, we're talking about what's going on here in Southeast Alaska. And this orange square, let's zoom into that. Now there is Sitka for reference, and now we're kind of looking at Baranof Island and where this is happening. What I'm going to talk about, it is on the eastern side of Baranof Island. So let's zoom in again. Now we're in Chatham Strait. And this is where my study took place, from Kelp Bay all the way down to Warm Springs. And the focus, where the whole story begins, is that yellow marker where there's a hatchery that's run by the Northern Southeast Regional Aquaculture Association. So here we are, an aerial view of Hidden Falls. This is a famous site for humpback whale predation on juvenile hatchery-release salmon. Now this is bad, right? You know, we have hatcheries to supplement the wild populations of salmon. So we want our fishermen to catch hatchery salmon so that there's a decreased fishing pressure on the wild populations. So if there's a whale in there doing something that we don't want to do, of course, this is a really important topic. It's not a new story. As early as 1999, actually, some of the workers at this hatchery have been reporting humpback whales feeding on the hatchery-released juvenile salmon. And in 2008, it was the first YouTube video, I believe, that was posted showing this. And Alan Chenoweth actually was the first researcher to kind of dive into this. It was her PhD project, and she was the first to document it, as well as she kind of dove into the economic impact that these whales might be having. So if you Google her name, you can find some of the really cool articles and stuff about that work to get some more background information. Okay, so when I mention this to people, most of the time people's big question that they ask is, how many hatchery salmon are they eating? This is a very good question, right? Pacific salmon, a very economically important fish to Alaska, to the world. And this is a very big question. Like science, a lot of the times there's these huge questions that are very difficult to answer, but we can move forward by breaking it down into smaller questions. But for my master's project, I sought out to answer this question. And it involved crossbows and cast nets and herring jigs and fishing poles and all this other stuff that is a story for another time. But the interesting thing is that when I sought out to answer this question, I actually discovered some answers to a question that we didn't think to ask. And so what I found was actually we should be asking how they are eating the hatchery salmon, and we were discovering that. So humpback whales are very innovative feeders. They use really ingenious methods for feeding. We know, for example, that they use their flukes, their tails, to slap the surface of the water, and this can stun prey. It's very well known that they use their blowholes to create these bubbles that can be used to corral prey. Now, for the purpose of this talk, I'm going to be talking to you about how they're using their pectorals in innovative foraging strategies. And when I say pectorals, I'm talking, people say flippers, and for the purpose of this talk, I'm just going to keep using pectorals. So they have a very distinct body morphology. Humpback whales are really interesting looking creatures, and by far they have the longest pectorals of any whale. It can be up to a third the size of their body. And with this extra length that they have, they use it for navigation, they use it for acceleration, they use it for maneuverability, stability. And the fifth is herding prey. So since the 1930s, scientists have hypothesized, have had this idea that humpback whales are using these extra long pectorals they have to actually herd prey. But it wasn't until this study we were actually able to document it. So over this work, we realized that there's three components to the use of pectorals to herd prey with humpback whales. The first is very simply just using the pectorals as somewhat of a barrier. The second is creating water motion with those pectorals to manipulate prey. And the third is reflection. Now, to better understand reflection, you really have to flip that whale over. And you can see on the undersurface of this whale, it's white. And so what many researchers have thought over the years is that these animals can use that white color to reflect sunlight and alter the direction that prey is moving. Okay, so we're back at the hatchery. Again, Hidden Falls Hatchery in Chatham Strait. Before I dive into what we found, there are two really important components that I want you to remember. So the hatchery is an extremely unique viewing opportunity to see these animals. If you're not exactly sure what you're looking at, on the right, of course, it's a humpback whale, and then on the left is this metal walkway. So at hatcheries in the ocean, they have these metal walkways that are squares, and there's this net hanging inside it where the fish are. And so that's floating on the surface. And so you can get extremely close to these animals, which is really important when you're trying to observe how they're feeding. When you're in a boat, you might not be able to get as close, as well as you might disrupt their behavior, and you're not seeing exactly what they would be doing if you weren't there in the equation. And this is really important, like I said, when you're looking at foraging behavior. And at the hatchery, you can essentially be inside a bubble net watching this behavior. So here you have one of those net pens, and you have a whale with inside blowing bubbles, creating that net and feeding. I honestly do not think you could get closer to a feeding event with humpback whale unless you were a fish in that whale's mouth. So the second thing I want you to keep in mind is that they're feeding on hatch-released juvenile salmon. So this is a new prey for humpback whales. They don't normally feed on these fish. They feed on krill, and they feed on naturally schooling fish such as herring. And juvenile salmon are not naturally schooling fish. So just keep that in mind. Okay, let's dive into it. The study was over 3 years, and in the first 2, I did systematic surveys up and down that coast. Again, the yellow markers where the hatchery is. And like I said, looking at how these whales feeding is not why we started this project. But during these 2 years, when I was collecting samples to answer that bigger question about how many they're eating, I saw something really interesting, and I decided to pursue it and document it as best I could. And I then decided in 2018, I wanted to document it even more in depth. And so I camped out at Hidden Falls Hatchery and collected more footage. So I started out, like most whale researchers start off, with a camera. And I found out really quickly that this was not going to be good enough. And to give you an example of kind of why, so this is what it would look like if you guys were sitting in front of me. I think you guys are definitely more colorful than these individuals. But an audience of people is very similar to trying to observe whales in their natural habitat in the water. So think of the seats as kind of the water line. And so when I take this picture with this camera, I can't really tell what's happening with these people in the back because I can't see below that water line, below the chairs with this perspective. So, you know, that individual in the middle is doing something with their hand. Maybe they're looking down, but I can't answer any more questions with this perspective. So I found out very quick, camera wasn't going to do it. Then in 2017, my mom got me a GoPro for my birthday. Thanks, Mom. And I had an extremely long pole and I had some zip ties. So I made myself what I called a poor man's drone. And it was great. It, again, this is what it would look like if I was using a camera, but that poor man's drone gave me this new perspective that was answering these questions that I didn't even know have any insight in with using that boat level camera view. And so now I know, apparently there's a baby in the audience, someone's eating potato chips, and then the individual on the right is reading a book. So changing perspective, giving me this new information that I couldn't tap into with a camera. So it worked great. I sprinted around the net pens as fast as I could whenever I would hear the bubbles, and I would put that pole as high as I could above the animal and record how this whale was feeding. So there's a few things with it that weren't that great. The first thing is I couldn't get high enough for some of the events. You know, I was limited to how that pole could go, as well as I was tethered to those structures, right? If a whale wasn't feeding next to those floating structures, I couldn't reach out and gather information. As well as it was really quite the workout. As you stare at this photo and are in awe of that humpback whale, I need you to stop being all of that and really just check out that squat form. I mean, that is on point. That is a workout for sure. So this worked great, and it definitely gave me more insight into what was going on, but I did finally end up buying a drone in 2018 and got more in-depth footage of what was happening. So before I show you this new feeding behavior, I have to give you a baseline. So I'm going to show you what a typical solo bubble net looks like. So you can see the bubble net in red, and then the whale kind of does a turn, very simple, and then it lunges. And I'm very sorry if this is kind of flip booky or very like buffery when you're watching it. We're gonna put a link at the end of the presentation to the video so you can watch them for yourself at home. But that is a simple bubble net. And let's dive into it. So what we found is that there were two whales, pelican and hobo, that were using this technique of pectoral herding. And the only difference between the two whales is that pelican was using it horizontally and hobo was using it vertically. Let's start with pelican. So again, this is newly documented feeding behavior called horizontal pectoral herding. All right, here we go. You can see the bubble net in red, and watch right here. Now I really want you to understand what you're seeing, so I'm actually going to reverse that video back to this point and change the angle. Now you're in front of the whale, and watch the right side of the screen, watch that pectoral move in and out of the water along that bubble net, and then there's the lunge. So I really want you to understand this. I'm going to break it down into figure form into 3 stages so we can really dive into what this whale is doing. Here's stage 1, and in all these figures, the prey is noted in yellow. So stage 1, this whale is creating this typical solo bubble net. And this is corralling the prey. And what happens with this bubble net, which you could definitely guess, is that the first bubbles end around the same location as the last bubbles, because it's a circle. But what this does is it potentially makes this a weak portion of that barrier, because these bubbles had been longer ago and they are dispersing, and so potentially that's a weak area, as well as the most recent bubbles that were created are potentially pushing that prey towards that weak portion of this barrier that they created. So stage 2 is where the magic happens. You have this whale hydrodynamically carving its pectoral in and out of the water along that barrier, along that weak portion with dispersed bubbles, and also condensing that prey into a smaller area within that bubble net around its mouth. Then of course you have stage 3 where the lunge happens. And so this whale used that pectoral to condense the fish, so this whale is getting more bang for its buck. Every time it lunges, more fish than if it just did the bubble net. So with that, sorry about that motorcycle in the background. So with that, we believe this whale is using its pectorals as a physical barrier, as well as using it to create water motion. So that's 2 of the 3 components of pectoral herding. We saw this whale over the 3 years, 73% of the time it was feeding. And now those feeding events, 58% of the time it used this solo bubble net technique. And every single time it used the solo bubble net, it used this technique of pectoral herding, 135 events with this tactic. And it was always on juvenile salmon. And so what we believe this boils down to is that this animal purposely was using this extra technique when it was feeding on this prey, hatchery-released juvenile salmon. Okay, let's move on from pelican and jump into hobo. So this is vertical pectoral herding. And this is a slightly different story. So right now, I'm giving you this aerial perspective of those net pens at the hatchery. Again, you've got those square walkways and the nets are hanging in the middle. So during this day, 100,000 fish were being released on the east side of these net pens. And of course, a hobo came in within 30 minutes of when this release was starting. So just perfect timing. And this animal did bubble net feeding in all these different locations. So all those orange squares are a location where this animal did a bubble net and lunged. And during those events, there were 3 techniques for how this whale lunged. The first was a side lunge, and this is very much similar to that first typical bubble net video I showed you. Then there's the streamline lunge, where you have these pectorals kind of down along the body. And then there's herding. So side lunge and streamline lunge are a typical behavior that we have seen whales use. If you've seen these whales lunge within a bubble net, you've probably seen one of these techniques. Herding is the new technique, and so I'm only going to show you the difference between streamline and herding so you can see the contrast between the 2 techniques. So here is a streamline lunge. Again, you have that bubble net in red. You can see the fish moving in the middle, and then the yellow shows that the pectorals are kind of out of sight back against the body. So very simple, hydrodynamic. Okay, here is the newly documented vertical pectoral herding. So you have that yellow, or the red is the bubble net, and then boom, check out those pectorals, outlined yellow, up, cupped around the mouth, almost like a referee saying the field goal is good, right? Extremely different than streamline lunge. So with that, we believe this animal is using its pectorals as a barrier to further condense those fish within the mouth within that bubble net. Okay, so it's extremely difficult to say or show that an animal is using its pectorals to herd prey, especially in this case where the movement isn't as dramatic as with pelican. And so how I'm going to help support our hypothesis of this whale using its pectorals to herd is I'm going to eliminate the other uses of pectorals during a lunge. So lunge feeding, extremely energetically demanding. It's a huge animal moving through the water, and it has to open its mouth while it's moving because it's got to get the prey, right? So this creates extreme drag. And the way it counteracts this drag is by using strong fluke strokes. So using that tail and pumping that tail to get to the surface to keep up the speed to catch these fast prey. And a lot of the time, the whale has its pectorals hydrodynamically neutral along the body, or it also can use these pectorals for acceleration or stability. Now I'm going to show you how the movement of hobo's pectorals quickly eliminates both of these as possibilities for the position of the pectorals. So hobo is simultaneously first rotating his pectorals at about 90 degrees. So imagine trying to swim to the other edge of the pool with your palms up. You're totally not going to be accelerating. And then second, this animal is pivoting its pectorals, and along the path is going perpendicular to the direction of travel and then cupping up around the mouth. So you're definitely not stabilizing yourself or accelerating yourself with this movement. And so with that, we believe what's left is this whale is using those pectorals to herd prey. Now, if you're still not convinced, which I cannot see you, but I can kind of feel that a few of you maybe still aren't convinced that this whale is purposely using his pectorals to herd, that's fine. I got you. There are 2 other components that support our hypothesis. So let's dive in. So we're going to start with prey movement. So here is a before and after snapshot of hobo placing those pectorals into that herding position. Now, we're going to zoom into that yellow circle, which is between the mouth and the pectoral. So we're zooming in, and in the before picture, you can see this dense aggregation of fish. And in the after, there's kind of a gap there. And in case it's very difficult to see this, especially over a presentation. So I'm going to overlay the dots on the fish. Promise, these are actually on fish. I'm not just trying to make my point by going in paint and throwing on dots. But you can definitely see now that the after shows that these fish have altered the direction and has changed, and there's a gap between the mouth and the pectoral, and there's actually this curvature of fish moving towards the mouth. All right, that helps. I like that. Let's move into sunlight. So during this feeding time, it was over like about 2.5 hours. Certain areas where this animal was feeding transitioned from sunlit waters to shaded waters. And so the purple is a bubble net and a lunge in shaded water, and the orange is in sunlight. And over here on the right, you can see there's several locations this animal fed that multiple times, but there was different light conditions in the area. And so what we found is that when this whale was lunging in the shade, it always used side lunge and streamline lunge. And almost every single time it was in the sun, it used this vertical pectoral herding. So this supports what the researchers have been saying in the literature, that they think that this white coloration on the underside of that pectoral can actually be used to reflect light and move those prey towards the humpback whale's mouth. This picture, of hobo feeding really shows that contrast between that bright reflective pectoral and then that dark mouth where those fish are moving. And that dark mouth is acting as this deceptive refuge because it's known fish behavior to go to the dark when there's a threat. So fish is like, cool, safety, and the predator's just like, yes, more food, right? So brilliant. So with that, we truly believe that hobo is using his pectorals as a barrier, as well as using this technique of reflection to further condense those fish and get more fish with each lunge. So 2 of the 3 components of pectoral herding. All right, so we got hobo, we got pelican, both of them using that standard typical bubble net to corral prey that we know humpback whales have been doing, but then taking it one step further, using their pectoral in a way that can condense those fish into a smaller area so they're getting more fish with each bite because we know how energetically demanding each lunge is for these animals. Okay, so do you remember when I said that, remember that juvenile salmon are a new prey for these animals? And we saw that they're using this typical bubble net to corral them that they usually use on naturally schooling fish, which is a typical prey, Pacific herring. Now, these two are 2 totally different beasts, right? Pacific herring are like machines. They're in sync, naturally schooling fish, tightly moving, which if you're a humpback whale and you're using a bubble net corral them, this is a brilliant prey for you, right? They're moving very tightly together in the same direction. So if you alter them, you're going to get a lot of fish with each bite. But like, check out those juvenile salmon. They have no idea what they're doing. They're loosely aggregated. Not only are salmon not naturally schooling fish, but these are hatchery fish. This is the first time they've been in the ocean. They have no idea what's going on. And so you could see why these whales potentially needed to develop or use this other technique to further condense those fish so they could get an effective amount of fish with each lunge. Okay, after all that, why do we care that there's these big fat guys in the ocean that are flipping around their flippers and moving fish? Like, why do we actually care? You know, why do we care about these 2 individuals? Well, there's several reasons. And let's kind of dive into the title of my talk. So let's start with these revelations from an aerial perspective. So again, like I said, I started off like many whale researchers do with this boat level view. And this is actually pelican using that horizontal pectoral movement. I saw this and I thought this whale was ridiculous. I thought it was chaotic. I thought this whale was uncoordinated, messy, couldn't possibly be effectively feeding, but just kept doing it over and over. And then I got that bird's eye view. And I realized this was not chaotic at all. This was graceful. This was calculated. This was intentional. Just changing that perspective, seeing the exact same event, I got so much more information about what was happening. And so after 90 years of scientists saying they believe these whales are using their pectorals to herd prey, we actually were able to document it. Finally able to document it because we have that aerial perspective. And then we took it one step further and we actually documented and discovered this new behavior where they were using it within a bubble net. So having this secondary barrier within this first barrier. So with that new technology, such as drones and small cameras, we're able to make these new great discoveries, as well as support something that scientists have been talking about for a long time. All right, how hungry whales work smarter, not harder. Okay, so you're probably thinking, Maddie, all right, these are just two whales, a pelican and a hobo, whatever, right? Well, it's really important for us to understand what's happening on the individual level if we're going to make any inferences about the population as a whole. These details matter, and these are top marine predators. And so their health and what they're doing reflects on things lower on the trophic level. So what they're doing helps us understand what's happening with krill, with fish. And so these details are really important for understanding those. All right, what if you're like, I don't care about whales? That's fine. Maybe you care about the fish. So the big question that we started off with, and most people ask again, is how many fish are these whales eating? Well, if you're going to tackle this question, you'd want to know how much a whale eats in a day, maybe know how many times these whales are lunging, and then how many fish are they getting with each lunge. This is very simplified how it would happen, but that's the basic kind of the back of the envelope idea. And so you would say, okay, that red is the bubble net. That's how many fish they're corralling with a bubble net. And then that orange is their lunge, and that's the fish they're getting, right? Well, you and I both know that's not true, because these whales are using a new technique that we didn't know about until we threw up a drone or threw up a pole. And so really your calculations would be so off, because this is actually what's happening. Those whales are condensing those fish, and they're getting more fish with each lunge. And this is what you need to use when you're trying to figure out those calculations and trying to figure out the impact these animals, this predator, is having on this economically valuable fish. And so this technique and this information can apply to many predators, and how we need to understand how they're feeding to really understand their impact on the fish and understand fish allocations and things like that. All right, what if you don't care about the fish? I mean, if you care about the whales, you don't care about the fish. I don't really know why you came to the talk, but there is another reason. So this is actually my favorite why care. And it's a great lesson to us researchers and scientists. And really, at the end of the day, it's just a great life lesson in general. And that is that we need to make sure that we're not being too rigid in our thinking and our curiosity, that we only find what we're looking for and we don't actually see what's happening around us, right? Again, you won't find this trying to figure out how they're feeding a hatchery fish or documenting whales using their flippers in any project proposal or application for grant funding. Because we went off script, because I followed some instincts, followed my gut, I was able to MacGyver these tools and get that aerial perspective and gain more insight into what was happening with these animals. So messages just go off script is absolutely fine. And I will leave you with a quote from one of my favorite researchers and mentors. Our overarching goal as scientists is to better understand the natural world. When we set out with a suite of specific objectives, we must also be open to new discoveries if we are to reach that goal. All right, if that wasn't enough detail for you, and you want some nitty-gritty information, you can Google pectoral herding and you can find this paper. It is open source, so you don't have to pay for it, and there's videos attached to it, so you can get all the details that you want. I want to thank everyone that was involved to make this happen, all the funders, collaborators, all the permits, everything that makes this all come together. And with that, I will take any questions. And my email's up there if you want to email me too, but I believe that Mandy or Nicole is gonna do that in the chat.
Madison, that was an absolutely fascinating presentation. Even though I got the little sneak peek version at the last Marine Science Symposium in January, I was just enthralled by this. And I know you couldn't see me, but I was laughing at all your jokes, I promise. So.
I almost put in just like a clip of laughing, because it's Yeah, there's a lot of silence. I'm glad you're actually still there. That's good.
Yes, yes. I was looking for like a little emoji, like a little laughy face or something to put on there. So I'm sorry through this technology that, you don't get to see the reactions. I know it's really tough, but I thought it was a really great presentation. And I'm going to encourage anybody, now's the time, if you have questions, please go ahead and put them in the chat box. I'm going ahead and I'm putting the link to Madison's, those whale videos. So that should be sent out to everybody. And while we're waiting for folks to go ahead and type their questions, I just want to say thank you to Madison. She put together this presentation and her time to do this on a completely volunteer basis. So we are very appreciative because we know it does take a lot of time for you to put things together, and you could be doing, other work or things like that. So thank you so much for taking the opportunity to speak to our group and share your research and your knowledge. It's really greatly appreciated. So little claps to Madison there. Also want to say thank you to everybody who's attending this presentation today. Thank you for caring about wildlife and these issues. And then thank you especially to our Alaska Wildlife Alliance members and supporters. Without your donation, we would not be able to offer these types of educational programs free to the public. And we, think it's very important to get the message out and to let everybody know about what's going on in Alaska's wildlife. So thank you. And we've got questions are coming in. So
I just want to say thank you so much to you guys, because especially at a time like this, it's incredible that you guys are, figuring it out and making sure this stuff is virtual, so that we all can stay connected and, take our minds off what's going on. So I appreciate you. I actually became a member today. So thank you, Alaska Wildlife Alliance. Really appreciate it.
Well, thank you so much, Maddie. We really appreciate that. So, okay, I want to get to some of the questions that are coming in here. And Maddie, you're also getting a lot of kudos. I'm gonna hit some of those first. Bravo, Maddie, fantastic talk. My daughter and I both really enjoyed this. Following your work. Oh, this is a question. Sorry, I'm gonna just give you some more of the kudos real quick. Fantastic job, Madison. Great presentation. Loved your graphics. Maddie's great. And this is exactly why we need science communication with these beautiful slides. So just want to make sure that that folks are loving your talk. And your presentation was very relatable, someone said. So good job on that. Really appreciated it. So,
well,
okay, I'm going to jump into some of the questions here. I know folks are really eager. So one question is, do you have any other questions that need to be answered regarding this research? Any other cool feeding processes that you've seen but don't fully understand yet?
Yeah, so to answer the first question, my second chapter actually kind of dives into that bigger question that I didn't really answer here about how many fish the whales are eating, and that's a really hard question to answer. And I use stable isotopes to kind of dive into that, and that's essentially just signatures within whale skin. So you are what you eat. And so, if everyone was here, I could take their nail clippings and I could use stable isotopes to figure out who's a vegetarian, who's a meat eater, who eats the most junk food. So there definitely are signatures that when you eat something, it's incorporated into you. And so I took samples from those whales. And because hatchery fish actually have this unique signature when they're first released, because they're fed this diet that has wheat in it, we were hoping we can actually trace that into the animals. Didn't work out exactly how we planned, because there's things called turnover rate where, it takes a while for when you eat something to actually see it in the skin. And we don't know that for these animals, because you can only figure that out if you have an animal in captivity and feed them something, change their diet, and then measure how long it takes to see that change in diet. So you can do it with dogs or dolphins, but we can't put a humpback whale in a pool. So long story short, we weren't able to really get completely at that question, but what we did find out is that those whales were, they looked like, with these signatures, that they were more fish-eating whales opposed to other whales in the area that didn't feed at the hatchery they look like they were eating more krill before the releases, during the releases, and after. So what this kind of tells us is either these whales already were kind of fish targeting whales, or because of the hatchery releases and they found them, they switched their habits. So it kind of gives us more insight into maybe why they're feeding there, and what's going on with that. I don't know if that completely answers the question that was asked. And then the second part, I can't remember what it was.
The second part is, are there any other cool feeding processes that you've seen but don't fully understand yet?
There was one. I hesitate to say too much about it because I hopefully can publish it at some point. But so I would watch it from the boat, and the whale kind of would wiggle a lot, and I would ask senior researchers, like, what do you think that whale's doing? And it was actually hobo, and they would say, oh, you know, sometimes humpback whales rub on kelp or rocks or things like that to, you know, get things off of their whale lice or whatever off of their skin. And I was like, okay. I just kept seeing this behavior, and it was just like looked like the whale was just kind of like wiggling. It looked super weird because you don't usually see you see them move and usually see they kind of look like an airplane or something, but really they have so much flexibility in their body and their tail and their spine and their pectorals. And so I threw up the drone and kind of documented this. And what I found, and I didn't get a ton of footage of it because it was only one day that I really saw this with the drone. I saw it over the 3 years, but only got drone footage of this 1 year. The whale was actually, so when the fish are released, there's tons in the water, but then after a while they start dispersing to other areas, and then in Southeast Alaska you have this edge where it drops off really quick, but there's this little lip where a whale cannot get in. It's not very deep water, right? And so the fish would hang out there, and during this time of year, there's not a lot of other prey in the area. Herring have already spawned, and so not very energetically appealing to humpback whales. And this is spring. Sorry, this is like late April, May, and in that period of time. And then krill aren't really that dense in the area yet. So these whales, you know, like this is a reliable prey source. They always know it's there, and it's something that they can rely on. And so this whale was wiggling a lot, and I was watching from a kayak when I was following the drone as well. And I realized it was actually moving its pectorals like this and creating all this motion in the water. And what I believe was happening is that the whale was actually scaring the fish. So when there's commotion, the whales will try to get away, and they can't go to shore because it's not really deep, but the fish want to go deep when there's a threat. And so what I believe was happening is the whale was moving its body, splashing the shore to get those fish to go off that little lip they couldn't get to. And then the whale would do this J of bubbles and then lunge. And so it was really cool to watch. And another example, I was by myself when I was doing this. So I was like so excited because like, this is crazy. They're not rubbing on kelp. They're trying to get the fish away. And I went around with my kayak and I did the same thing with my paddle, and I saw the fish do the exact same thing. So it was really cool. I'm hoping to maybe get more footage of it at some point in the future. So, you know, really solidify the hypothesis. But that's an example of something that also is pretty cool.
That is, I'm really looking forward to a future Wildlife Wednesday of your wiggling whales.
Yeah, right?
I think that'd be really fascinating. So let us know when you're at that point, and we'll see if we can schedule another talk to share that great information.
Sounds good. Great
Okay,
question.
Another question. This one came from Illyria. Following your work, has this behavior been documented at any other hatcheries in Alaska?
Yeah, that's a great question. So with that question, just to explain, this is actually happening in a lot of other hatcheries. It really first was hit hard at Hidden Falls, and they get a lot of attention because they were having run failures, which means they weren't having enough adult fish return to supply the eggs for their new fish. And so that's why there's a lot of focus on that hatchery. But it happens in Ketchikan area, it happens in Juneau, and it happens farther south in Chatham Strait. So this behavior, humpback whales feeding on juvenile salmon, is not just isolated in that location. You know, again, it is a lot of fish at once, and it's consistent year after year. So these, I mean, as a wild animal, you're stoked if something's consistent. And I'm not sure, it's actually happening in Sitka now too, over there at the hatchery, which is crazy, on the other side of Baranof Island from Hidden Falls. I'm not sure if it's happened at the hatchery, but since I've kind of put this work out there, people have seen it, and they've sent me videos actually from Juneau of a whale, and it's not straight above it, but you see kind of the splashing movement and then a lunge. And so the thing that's really important to know about this research and this project is that, you know, I think they use it for more than just hatchery fish. I think they use it a lot on hatchery fish because of the reason I explained, but I think this is happening a lot. And again, they have those long pectorals, and so scientists have thought they've been using it a lot. So definitely have seen it in other areas, and people have said they see it in Juneau. Just need to get some drones up to really capture it. But I think that's another good lesson of, you know, sometimes some people told me not to publish this because it was just 2 whales and it wasn't a lot, but I think a really good lesson is that if you don't put out these kind of smaller studies, you won't find out that it's actually happening on a bigger scale, because people think, oh, I shouldn't share it, you know, whatever, that's not significant. But when you do share it, then you start seeing, oh, it is bigger than we thought. It's happening here, it's happening here, it's happening there. And so you make these big connections. So I guess I would encourage, you know, don't give up on little studies all the time. They're helpful for bigger picture questions.
And you know, you just, I think, answered a question I had as you were talking of, I know you focused on hobo and pelican, but I wasn't sure, were those just, you know, a subset examples of all the whales you were seeing, or were those the only 2 that got documented at the hatchery? So I'm just kind of wondering I know the behavior was seen in those 2, but out of how many whales that you saw come through the hatchery was this behavior represented?
Yeah, good question. So over I guess, I'm trying to think, I guess like 2008 is when our lab started really following it. And Jan Strelly created this great relationship with the hatchery, and the hatchery has been awesome in letting us work over there. Because of course it's not a great thing for them, you know, they're trying to figure things out, and we're trying to help. But in those years since 2008, we've only seen these 3 whales. So sorry, there's hobo, pelican, and there's another whale, PJ, which I didn't talk about. And those 3 whales come back year after year. Sometimes you have drive-bys, and when I say drive-bys, I mean a whale that comes by, maybe feeds on some juvenile salmon, and then they kind of leave, and you don't really see them again. And I would be out there, you know, every day whenever there's good weather for 3 months following these whales at the hatchery. So you really see what's going on. And so who knows why those 3 stick around? Again, maybe it's because, you know, from that other work, you know, they really focus on fish, and these are the fish in the area at the time, while these other whales are somewhere else trying to find a different prey. And this is really early in the season, so maybe some whales haven't come back from Hawaii yet. And so kind of got lost in my thoughts. Oh, so yeah, so 3 whales have been doing it, and then the other whales in the area are mostly you don't see many in the area at the time, and they're kind of maybe just coming and cruising by and leaving, going to different places, trying to find krill or whatever. And so the reason people always ask me, well, why isn't PJ doing this? You know, why, if that's another whale that's feeding at the hatchery. I wasn't able to get a drone over PJ, so I only had that drone that last year. And PJ wasn't as courageous around the hatchery as the other 2, if that's the right word to use. So hobo kind of comes in and acts like he owns the place, like gets really close to buoys, doesn't care about boats, just like rubbing everywhere. And pelican really gets in there as well. Well, PJ kind of kept the distance. Actually, in 2017, I didn't see PJ at the hatchery at all. Could have gone there, you know, I'm not there at night, but was in another bay where all the hatchery fish are. And I would catch the prey and take out the otoliths, so I knew they were hatchery fish. So not certain, you know, maybe PJ does do it and I didn't see it, or maybe just a different technique, because again, these are really interesting animals that use a lot of different techniques. So who knows what's going on, but I did see one year, 2017, another whale that wasn't a hatchery whale come by and use that horizontal pectoral movement on the fish. I thought it was pelican. I'm like, oh, it's pelican, easy. And then I looked at the photos, like, that is not pelican. That's a new whale doing this behavior, and I didn't see that whale again. So that could be something, you know, either they're learning it, or all the humpback whales kind of already know that there's a good reason to use their pectorals. Again, just who knows, but it's really interesting stuff.
Yeah, thanks. There's so many other questions that pop in my head, but I want to get back to our participants. I could totally monopolize your time. So Damien asked, I know it's a very complicated issue, but do they have a big impact on the population of juvenile salmon? If yes, what could that mean? Moving hatchery, coming back to control the population of humpbacks? What do you think?
Yeah, that's a good question. That's a really, really hard one to answer. So we are hoping that we could potentially figure out the proportion of these whales' diets. So like, at this time we were hoping we would figure out maybe it was 50% hatchery fish and 30% herring or something like that, but we weren't able to do that. And so it's very difficult to calculate how many they're eating. I personally think that if you eliminated those 3 whales, because a lot of people say, why don't you just kill those 3 whales? There's just 3 whales killing it. And I mean, I'm not like if that worked, sure, I don't think it would work. I think you would easily have new whales come in and kind of fill that niche. And again, it's happening in many hatcheries and not just Hidden Falls. So just killing those 3 whales, and there's a lot to kill a whale. It wouldn't be that simple. It'd take some money. And so I don't think killing those 3 would solve the problem. And I also don't think taking those 3 whales away or taking the whale predation away from that hatchery would solve all of the hatchery's problems. I think, that hatchery's been running for a very long time. I can't remember the exact date. I think like decades they've been running. And so if you're releasing that large of biomass of prey in the same location year after year, I mean, when you're at that hatchery, there's like 40 eagles in the trees diving down to get fish. There's seals that are so flat, they're just like floating, like I can't take any more, and then they eat more. And so I don't think eliminating them would solve all the issues. And what the hatcheries start doing, actually, they pump the fish into fishing boats, and then they take the fish and they drive across Chatham or to different locations, and they release the fish there. And that, they think potentially they just kind of started doing that, so they haven't figured out if the returns, if it's working yet. But that kind of eliminates those 3 big predators, as well as those other predators that know that's where to go when there's food. Obviously that opens up other problems, of predators in different areas or changing kind of ecosystems in different areas than just where those fish were. So it's very complex, and there's going to be a lot of research in the future, and there already is a lot of research right now going on about the controversy with hatchery fish and wild fish, and so a lot of good people and organizations are diving into that to kind of tap into those questions.
Great. And I'm looking, we've got a question from Karen, but I think we kind of already addressed it. She asked, have you documented other whales beside these 2 feeding this way?
Yeah, so one other whale using that horizontal pectoral herding, have it on video, and definitely have dorsals, so it's a different whale for sure, confirmed that. And then again, I got some video from someone in Juneau that, it wasn't a drone shot, it was kind of on a hill looking down, so you can definitely see that movement. It's hard because some people say, oh, I for sure saw that too, and you're like, well, did you? Because that boat level, it's hard to see, but definitely that Juneau one, I think for sure that whale was doing it. So yeah, I think it's happening out there a lot. I think the big thing is, again, the perspective, as well as there's not a lot of studies done on humpback whales feeding in solo bubble nets. There's more happening now, but a lot of the drone work in the past has been done on just those big groups of humpback whales, and putting up your pectorals when your friends next to you is not going to be, a good idea. You're kind of just using them as bearers to push fish into your mouth. And so this, focusing on these solo bubble netters, you're getting more of these intricate details of how they feed solo.
Great. And I think that's the last question I see from the participants. And I know we're a little bit after 8 o'clock, so I want to just thank everybody for hanging in there with us. And, we'd love to know where you guys are, calling in and joining us from. So if you wouldn't mind just letting us know before you sign off on the chat, that would be great. Also, just a reminder, we would really love for you to be a voice for wildlife. And if you have issues with some of the proposed changes regarding the Kenai rule, we put the link to learn more about it in the chat, and we encourage you to go ahead and submit a public comment before that Monday deadline. And we would really appreciate that. And Madison, I just want to let you know that Beth said many thanks. She's appreciative to our guys and to you personally for taking the time to share this fascinating info with us. So kudos again from our participants on what a great job. And so
kudos for the questions too. You guys were very engaged, so great questions and some hard ones as well. Yeah,
we have a great member base here and supporters on these and really engaged in this. And I just have one more question. Do you know if hobo or pelican, or I think it was PJ maybe, are any of those whales related? So do you think this is like a learned behavior within a family group, or you know, how are they, do you think it's just an innate feeding style?
Great question. We actually had that question. We ran genetics on them, and no, they are not related. So they're either. It seems like maybe, I mean, you never see them feed together really, and I've kind of seen it a little bit where they might do a bubble net close to each other and then lunge, but they kind of keep their distance when they're feeding on the juvenile salmon. So it seems like they're definitely, you know, that's their own show. They're not really, they're kind of like, you know, if we all went to the grocery store at the same time, doesn't mean we came together. We're just there because we need some food, right? So yeah, not related. So yeah, good question.
Well, great. I'm not seeing any more questions coming in. Oh, and I've got that Damien said that Damien's absolutely obsessed with whales since the close encounter in Lowell Point. So that's great. Damien's now in Anchorage and moved from Poland last year. So you are internationally respected now, Madison. So.
Well, welcome to Anchorage too. That's awesome.
Yeah, absolutely. So, well, I think with that, we're going to go ahead and conclude our Wildlife Wednesday today. Thank you so much for joining us. Thank you, Madison, for the really amazing presentation, very educational and presented in a way that was really understandable. So really kudos to you for that. And thanks to everybody for attending our presentations. Without you, we wouldn't have a reason to do these. So thanks everybody, and hopefully we will see you next month at our talk. Have a good evening.
Awesome, thank you.
Thanks, Madison. And we'll just stay on a little bit longer so people can send any last minute kudos in the chat, but we'll see you, we'll wave you all off as you sign off. So thank you.
I can say if there's any other questions too, I don't mind. I mean, I have to run to the grocery store and get some vegan A's, but besides that, I'm good.